Hi there, folks. This is the review for the Unit 3 test, and I am the amazing Mr. Jansen. Let me put my name on my paper. So here we go. When we look at these first couple, it just says to write the inequality for each graph. And so when I look at the first one, the first thing I notice is that this thing is an open dot. I see that this thing is open, which means I'm not going to have an equal to condition, and I'm shading to the left of this thing, so I have all the values that are smaller than that value, so it's going to be a less than. So I'm going to say x is less than the -1, and that's it. Again, it's less than because it's to the left, and it's no equal to condition because it's an open dot. The next one, the first thing I notice is that there's an equal to condition because there's a closed dot, and then I'm shading to the right, so it's going to be a greater than, so I'm going to say x is greater than or equal to, again because of the closed dot, that positive 3 it looks like. The next one, this is a compound inequality. This is an and inequality. Whenever we have two things that are shaded in between two values, you know it's an and inequality. And when we write the and equality, essentially my x value is between a -2 and a +1. So we're between those two values. And we look, we're smaller than the +1, but we're bigger than the -2. And that's kind of how I approach this thing. And when I look, again, there's no equal to conditions because they're both open dots. All right? When I look at the next one, this is an or inequality. Or inequalities kind of have two separate pieces that go in different directions. So I just identify each piece individually. The first piece is showing me that x is less than a -4. Again, it's less than because it's to the left. No equal to condition because it's an open dot. Or, I put the word or in between. The second piece of this thing is showing me x is greater than or equal to the 2. And again, it's greater than or equal to because of the closed dot, and then we're shading to the right. The next one, once again, it's an and inequality. It looks like I'm going from -3 to +2, and my x value is in between those two values. I'm smaller than the 2, but I'm bigger than the -3. And then because of the closed dots, I'm going to throw those equal to conditions in there. Okay? Another or inequality, just list each one separately. So x is less than or equal to the -1. That's the first piece. X is greater than or equal to the +1. And then I put the word or in between. Okay? For each of these, I'm just going to solve each and then draw a quick sketch of the graph. So the first one, I have to divide each side by the -8. When I do that, because I divided by a negative, I have to flip the inequality sign so it becomes a greater than symbol. That gives me the -6. Okay? And now the quick sketch of the graph here. Again, I just slap -6 in the middle. Put a couple values around each side. So like over here would be -5, over here would be -7. And now from here, I'm going to use an open dot. And you can graph it on the line or above the line. I always do above the line. And then I'm going to shade to the right because it's greater than. Okay? The next one, the first thing I want to do is go ahead and distribute. That's what most folks are going to do. You could divide each side by the 3 right away. I'll distribute. That's a 6 minus 3x is greater than a 9. And now I'm going to subtract the 6 from each side. Again, just like when we solve equations, I'm working backwards through order of operations, undoing the operations as I go. And now I'm going to divide by the -3. The only big difference between solving an equation and solving an inequality is, remember this step right here, I divided by a negative, so I have to flip that inequality sign. It's going to be a greater than symbol now, and I'm going to put the -1. All right? And so again, once again, when I graph this thing, I've got the -1, 0 would be here, -2 would be over here. There's no equal to condition, so I'm going to use an open dot, and I'm shading to the right because it's greater than. The next one, once again, I'm going to use my distributive property, so I'm going to distribute that too. And then from here, I got to get the x's on the same side. Again, my recommendation is to always deal with the x's first. Move the x's before you do anything else, so I'm going to subtract the 2x from each side. Okay, get those x's together first before you actually start solving this thing. So we got a 2x minus 6 less than or equal to that -8. And now I can undo order of operations by solving, working backwards through order of operations and undoing the operations as I go. So I add the 6 to each side. And now I can divide each side by the 2. And this time I didn't divide by a negative, I divided by a positive, even though I get a negative value here. So this time I do not flip the inequality sign. All right. And again, the quick sketch of this thing, if I'm looking at the -1, 0 would be up here, -2 would be down here. I'm going to use a closed dot this time because there's an equal to condition, and less than means I shade everything to the left. Okay? So my actual answers for these are the inequalities. The graph is just there to kind of help me check this thing. All right? When I look at the next one, again, I'm going to use my distributive property to start. So I'm going to distribute that -3. And now, oops, sorry, there's no equal to condition on this one. And now I'm just going to combine like terms, just like I would if I was solving an equation. That's a 4x. And now I'm going to solve this thing. I'm going to subtract the 6 from each side. And then divide by the 4. So again, I'm still doing the same things that I've done when I was solving equations. The only difference is if I multiply or divide by a negative, I have to flip that inequality sign. And then again, a quick sketch of the graph. 4, 5 would be above, 3 below. And I've got no equal to condition, so a closed dot, and less than I shade to the left. Okay. And the next one, I'm going to start right away by subtracting the 16 from each side. So in this one I end up with a -7x is greater than or equal to a 21, and now I divide by the -7. And again, because I'm dividing by a negative, I have to flip that inequality sign. Don't forget to flip the inequality sign in these, okay? And now when I do my graph, I've got -3, -2, -4. Again, I just put a value on each side of it just to give me some context as to where this thing is. Closed dot because the equal to condition, shading to the left because it's less than. Okay. This one, as soon as I see all those fractions, I think, well, I don't want to deal with fractions. So remember, to get rid of fractions on these things, you want to multiply through by the common denominator. Just like we did with equations, I'm going to multiply everything by the common denominator. And when I look across here, the only denominator is 2, so I'm going to multiply everything by 2. So I'm using my distributive property here as I multiply. 2 times 3 halves gives me a 3, so that's a 3x. Minus 6, less than, as I distribute on this side, that gives me a 2x plus 5, and then a minus x. All right, now it's just going to be combining like terms, getting my x values together. So over here I combine like terms, it gives me the x plus 5. Now deal with the x's first. I'm going to subtract the x from each side. Now I'm going to add that 6. And then I'm going to finish solving by dividing each side by the 2. And I'm just going to leave it as an 11 halves, okay? And now here's the thing. When we go to graph this thing, just to put this in the perspective of some context, so that's 11 halves, which is really 5 1/2. So if I go above that value, I'm at 6. If I go below that value, I'm at 5. Okay? And again, just to give this a little bit of context to kind of show me where this thing is. All right? Open dot, shading to the left. Okay? Look at the next couple. The next couple are compound inequalities, which really for OR just solving 2 separate inequalities. For an AND, it's solving 2 separate inequalities, but we're going to solve them simultaneously, so at the same time. And then there's one little extra piece on this guy. It says right here to write the answer in interval notation. So we're also going to write it in interval notation when we're done. All right. So when I look at this first one, this OR inequality, it's just 2 separate inequalities that I solved. So like this first one, I'm just going to add 3 to each side. So I'm just solving this first inequality. And again, there's just 2 inequalities listed. So over here, that gives me a -8. And now the second inequality, I'm just going to solve this guy separately. So I'm going to divide each side by the 3. And I get this. And I just transfer that little OR value right here. So this is going to be my answer. Oh, sorry, we want to convert that to interval notation. And for interval notation, for some of us, it's going to be really helpful if we just graph this thing first. So like if you think of this guy on the number line, you got your -8 here and your 4 here. If you think about it this way, it's always negative infinity down at this end and positive infinity down at this end. And sometimes that's helpful just to put on our graph in terms of interval notation. But then from here, we know that we're going to shade this way on the graph, and then a closed dot here and shade this way. And as we transfer that to interval notation, essentially we're starting at negative infinity and going to negative 8. And then we're going from 4 to positive infinity. I'm just marking the start and stop points. It's always a parenthesis for infinity because we can't equal it, parenthesis for the negative 8 because there's no equal to condition, a bracket for the 4 because there is an equal to condition, and a parenthesis for the infinity. And then I just use my union symbol to put in between here. Remember, the union symbol is the same thing as saying an OR type of inequality. All right. The next one, same kind of thing. Look at where the variable is. The variable's in the middle, so I want to undo the stuff that's in the middle. So here I want to add the 7 to that middle. Whatever I do to the middle, I have to do to the outsides as well. So it's 3 different sides that I have to add that 7 to. So that gives me a 4 less than or equal to the 2x less than 16. And now again, where is the variable? The variable's in the middle. Undo the stuff that's in the middle. To undo that times 2, I divide by 2. Whatever I do to the middle, I have to do to those outsides. Okay, so I do it to all 3 sides. Here that gives me a 2. Here it gives me an x. And here it gives me an 8. And once again, if it is useful, graph this thing first. Okay, when I think about the graph of this guy, I'm going to shade everything that's in between these 2 values, closed dot on this end, open dot on this one end. Okay, that's how I graph that and inequality. And so when you look at it in interval notation, I'm starting at the 2, I'm going all the way up to the 8. There's a bracket here because of equal to conditions. There's a parenthesis here because there's no equal to condition. And that's it for interval notation. Okay. The next one, same kind of thing. I'm going to solve each of these individually. I'm going to subtract the 5 from each side. And then I'm going to divide by that 3. And again, I'm just going to leave it as a big fraction. It's x is greater than or equal to 14/3. Just leave it as an improper fraction. Now the next one, I'm going to solve this guy as well. I add the 6 to each side. And then I'm going to divide by the negative 2. And once again, because it's an inequality, if I divide by a negative, I have to flip the inequality sign. It becomes a less than negative 5. I put my word or back in between. But now in terms of interval notation, again, go to the graph if you need to. But hopefully you can see that, okay, if we're less than a negative 5, that's from negative infinity to negative 5. Parenthesis for each. The union symbol. If I'm greater than or equal to the 14/3, that's a bracket for the 14/3 and going all the way up to positive infinity. Okay? And that's it. The next one, once again, I see fractions and I think I would love to get rid of those fractions, so I'm going to get rid of those fractions by multiplying through by the common denominator. The common denominator here between the 2, the 3, and the 6, again, you got to look at all those denominators, is going to be a 6. So I'm going to multiply every side by 6. Whatever I do to that end side, I have to do to the middle. Whatever I have to do, and I also have to do the same thing to the other side. Okay, so I'm multiplying everything by 6 using my distributive property. So here, this guy's going to give me a negative 9. 6 times the 4/3, that's going to give me an 8. So that's an 8x. Minus 18, less than or equal to a 5. And now, once again, I look at where the variable is. The variable's in the middle, so I undo the stuff that's in the middle. I add 18. Got to do it to all of the sides. And then once again, the variable's in the middle. I'm going to undo what's in the middle. I'm going to divide by 8. I have to do it to all of the sides. So here, and then once again, I'm just going to leave this as a fraction. That's 9/8 less than x less than or equal to the 23/8. Just leave them as improper fractions. They're great that way. So this one goes from 9/8 to 23/8. Parenthesis for the 9/8, bracket for the 23/8 because of the equal to condition versus no equal to condition. Okay. The next one, we've got a family of 3 going to the fair. It's 2 adults and 1 child. They have $245 to spend. Admission is $15 a person, and each ride ticket costs $4. For each ride, the child will be accompanied by one of the adults while the other watches. Okay, so only 2 people are going to be riding each ride, and we want to figure out how many rides they can go on. All right, so there's 2 components to this thing. The first thing is we have to figure out how much they're going to pay to get into the fair. So we have to figure out the price of admission. All right, and so the price of admission here, because there's 3 of them, and it's $15 for each, we're just going to do 3 times 15 and say, okay, the price of admission is $45. All right, so we know they're spending that amount. And then we have to figure out how much it's going to cost them for each ride. Okay, this is the other thing they're spending money on. Okay, so each ride. And so when we think about this, each ride is $4 for the ticket, but 2 of them are going to ride. So we have to do 2 times the 4 for each ride. Okay, so essentially each ride is going to cost them $8. All right, so when we think about how many rides they can have, it's $8 for every ride they ride plus the $45 for admission. So basically the equation we come up with here, if I say R is the number of rides, I'm going to say 8R plus 45 has to be less than or equal to the $245. Again, it's $8 per ride plus the $45 they spent to get in. That has to be less than or equal to the amount of money that they have. And now I'm going to go ahead and solve this thing. So here I'm going to subtract the 45 from each side. That's an 8R is less than or equal to a 200. And now I'm going to divide by the 8. So that gives me R is less than or equal to, looks like a 25. Okay, and that's 25 rides. So they can ride at most 25 rides or less. All right. For these guys, absolute value equations, remember, we're just going to split these into 2 separate equations. What's inside the absolute value could be a positive 13 or a negative 13. Either one of those, when I take the absolute value, will give me the answer of 13. So that means the 2x plus 5 could equal a 13, or the 2x plus 5 could equal a negative 13, and I have to solve each of these. So I subtract the 5 from each side, so I'm just solving 2 separate equations. 2x equals an 8, divide by the 2, and I end up with x equals a 4. Okay, so that's one of my answers. I have to find another answer by solving this other equation. I'm going to subtract the 5 from each side. That's a negative 18. I divide each side by the 2. And I find out that x equals a 9. A negative 9. All right. And the last thing I have to do when I'm looking at these guys is I have to plug these back in and make sure that they work. And just do a quick check. 2 times 4 is 8 plus 5 is 13. Absolute value of that is 13. 2 times negative 9 is negative 18 plus 5 is a negative 13. The absolute value of that is positive 13. So both of these work when I plug them back in. You have to do that because sometimes you'll get extraneous solutions. Okay? This next one's kind of interesting because when we look at it, the first thing we notice is the absolute value is not by itself. You have to get the absolute value by itself before you can split it up. So here I'm going to subtract the 7 from each side. Wow, that's an ugly looking 7. Let me try again. There we go. So we subtract the 7 from each side. I end up with the absolute value of 4x minus 3 equals a negative 3. And the thing that's really interesting about this one is right now it says the absolute value equals a negative 3. And the one thing we know about the absolute value is that it's always positive. So if the question says, when will the absolute value equal a negative? Well, the fact of the matter is it won't. The answer to this one is no solution. Okay? And the second we see absolute value equals a negative, we can say no solution. Now, however, if you split this thing up, if you were to split it up into a 4x minus 3 equals a negative 3, and then do the 4x minus 3 equals a positive 3, you could solve each of these. I'm just going to do it real quickly. I'm not going to show my work. Okay, add the 3, divide by the 4. Here, add the 3, divide by the 4. what you're going to find is as you get these two solutions, you got to make sure to plug them back in. If you plug these back in, neither one of these will work. If you plug the 0 in, you get 4 times 0 is 0, minus 3 is a negative 3. The absolute value of negative 3 is a positive 3, and when you add that to 7, you get a 10, not a 4. All right? If you do the 3 halves and plug that guy in there, okay, you're going to get a 6 minus 3, which is 3. The absolute value of that is 3, plus the 7 is a 10. Once again, it doesn't give you a 4. All right, so neither one of these answers work. These are extraneous solutions. Even if you've done everything right, you're trying to solve an impossible situation. So make sure you plug your answers in. This one is no solution. Okay? The next one, once again, we got to get the absolute value by itself, so I'm going to subtract the 5 from each side. That's going to give me a 1/3. 1/3 absolute value of x minus 2 equals 2. And now from here, the absolute value is still not by itself. I have to get rid of that 1/3. To do that, I'm going to multiply each side by 3. So now I've got the absolute value of x minus 2 equals a 6. Now I can split this into two separate equations. Now I can do the x minus 2 equals 6 and the x minus 2 equals a negative 6 and solve each. So this one I'm going to add the 2 to each side. So I've got x equals 8. On this other one I'm also going to add the 2 to each side. So I'm going to get x equals, looks like a negative 4. Okay, and again, plug each of those back in. When you plug those back in, you'll find that they do work. All right? This one for absolute value inequalities, we're going to do kind of the same thing, same approach. I'm going to split it up. So I'm going to do the x plus 4 is less than the 12. And then I'm also going to do the x plus 4, and I'm going to use a negative 12. The big difference with the inequalities, just like solving equations versus solving inequalities, is I have issues where I have to flip the inequality sign. This is one of them. I have to flip that inequality sign and do a greater than symbol for the second half of this thing. Now I can solve each of these. So I'm going to subtract the 4 from each side. Over here, I also subtract the 4 from each side. And now from here, I have to decide what kind of inequality this is. Is this an and inequality, or is it an or inequality? And the thing you do is you go back to when the absolute value is by itself. And for this one, it's this step right here. Here, the absolute value is less than the 12. Remember, absolute value is less than is an and. Greater is an or. So if it's a less than symbol, it's an and. If it's a greater than symbol, it's an or. So this one's going to be an and, so I have to slap that word and in between there. And you can circle that. That could be our answer, but it's more appropriate to write it this way, 16 less than x less than the 8. Okay? With the ands, we can write it as one string like this. It's a nice, neat, succinct way of writing it. Okay? Next one, same kind of thing. The absolute value is by itself, so I split this thing up. So it's greater than or equal to the 11, but then it can also be less than or equal to the negative 11. Again, you got to flip that inequality sign. And now from here, I'm just going to start solving. So here I'm going to add the 4 to each side. I'm going to divide by the 3. On the other side of this thing, I'm going to do the same kind of thing. And really, it's even the same steps when we split these things up. And that's what's really nice about it. I'm adding the 4 and then dividing by the 3 each time. And this one, once again, anytime I have something that looks like this, just leave it as an improper fraction, as a negative 7/3. And now right here, when I look back up at where the absolute value is by itself, the absolute value is greater than, so it's going to be an or. When I look at the next one, the absolute value is not by itself, so I have to get it by itself. So I'm going to subtract that 5 from each side, or sorry, add that 5 to each side. That's how I undo subtraction. And now from here, I'm going to split this into two inequalities. The first of which is the 4b minus 2 is less than or equal to the 14. And then I'm also going to do the 4b minus 2 is greater than or equal to the negative 14. And now I'm going to solve each. And it feels like some of these are a little bit repetitive. It's because they are. I'm going through the same process each time. And especially when I'm solving the absolute value inequalities, it becomes extra repetitive only because I'm literally solving the same inequality each time with a different value on the other end. So like here I'm adding the 2 and then dividing by a 4. I'm going through the same steps for this guy as I just did a moment ago. And then from here, I get the b is greater than or equal to the negative 3. All right. And now, once again, I need to decide if this is an and or an or. This one is an and once again because, and again, I go back to this step right here. Absolute value is less than the 14, so this is going to be an and. Once again, you could put the word and in between here. The more appropriate way to write it is negative 3 less than or equal to b less than or equal to 4. And that's it. Okay? On the next one, the absolute value is not by itself. I have to get it by itself, so I have to divide each side by that negative 2. And the thing that becomes a little bit tricky here is, again, I'm dividing by a negative, so once again I have to flip that inequality sign. So it's going to become a greater than, and this is going to be a 4. Now I can split this thing up. It's going to be a 2w plus 4 is greater than 4. And then 2w plus 4 is less than a negative 4. And now I solve each of these. Just undoing my order of operations as I go. And I solve the next one, subtracting the 4 and then dividing by the 2. And then the last thing I have to do here after I finish solving this guy is I have to decide if this is an and or an or inequality. And when I look at this one, the step I have to look at is when the absolute value is by itself. I got to look at this step right here, which says the absolute value is greater than, so I have to do an or in between these guys. This one's going to be an or inequality. Okay. This one says quality control for a candy company require 4-ounce bags of candy to have no more than a 0.2 ounce margin of error. Express the acceptable range of values as an inequality. And so when you look at something like this one, notice it didn't even say that we had to write an equation. Hopefully you can look at this and start to figure out, okay, if it's supposed to be 4 ounces, but it can be 0.2 ounces off, that means the lowest it could be would be 3.8 ounces. The highest it could be would be 4.2 ounces if it's off by 0.2 in either direction. And so our acceptable weight is going to be in between those two values. Well, this is just a compound and inequality, and that's my answer. Okay? And here's the thing. We can solve this one doing an absolute value inequality. We could say if I do x minus the 4 ounces, that should be less than or equal to 0.2 or negative 0.2. In other words, the absolute value of that. And you could solve this and say, okay, x minus 4 is less than or equal to 0.2. X minus 4 is greater than or equal to a negative 0.2. And then solve each. And you're going to get the same values. But again, with this one, because it didn't ask me to do this, I absolutely do not have to do this. And so if I can come up with these values without doing all of this, that is fine. And I just have to write this thing as a compound inequality. I'm going to finish solving this thing just in case, and just to show you that it's the same values. But again, because it didn't require me to do this, and yeah, once again, it's an and inequality. Wow, that is a terrible looking D. Let me try again. Because it doesn't ask me to do this, I can go right to the answer here if I would like. Okay? For these, just says determine if each statement is true or false, and this is asking about subsets. Remember, a subset is when one set is completely contained inside another set. So if everything from this set is in another set, it's a subset of that guy. So it says A is a subset of B. So when you look at the values of A, we've got -3, -1, 0, 1, and 3. If all of those values are in set B, then A is a subset. And when you look, we've got the -3, we've got the 1, we've got the 3, but we don't have the -1, we don't have the 0. So all of the stuff from A is not in B, so A is not a subset of B, so that's a false statement. When I look at the next one, B is a subset of A, so now all the stuff from B has to be in A. So let's see, I see the -3 is in there, I see the 1 is in there, I see the 3 is in there, but the -2 is missing. So all the stuff that B has is not there, so I can't say that that's a subset, so this one's also false. The next one says C is a subset of B, so I look at C and say, is all the stuff from C in set B? And when you look, the -3 is there, the 1 is there, and the 3 is there. All the stuff from C is in B. So yes, C is a subset of B. That's a true statement. And then it says A is a subset of C, so is all the stuff from A in set C? And the answer is no, it doesn't have the 0 or the 1 or that kind of stuff, so that's a false statement. This one, B is a subset of C. Again, is everything from B in set C? And the answer is no, it doesn't have the -2 or the 1, so that's false. Is C a subset of A this time? And when you look, -3, 1, and 3, yeah, all of those things are inside of A, so that is a true statement. And then this one, it says, is the empty set a subset of B? And the thing we have to remember about the empty set is it's always a subset of every set, so that's always true. This one, same thing, is the empty set a subset? Yes, it's always a subset, no matter what. The empty set is always a subset of any other set. And that's why those last two are true. Okay? For this one, the first thing I would do here is the two that are listed in terms of words, I would rewrite those in terms of the actual values. So set B says that X such that X is a positive even integer less than 9. So if you think about positive even integers less than 9, that would be like 2, 4, 6, and 8. All right, so that's essentially what this set is saying. If you want to rewrite set B as just those values, that's fine. D, X such that X is a negative integer between -6 and -1. Notice it says between those values. It doesn't include those values. So that would be -5, -4, -3, and -2 for that set. Okay? And so now when I look at these, the union symbol means I just combined the two sets into one. So A and D, I just combine them together. So I list everything from A and everything from D together. And so when I do that, let's see here. That's going to be a -5, a -4, a -3, a -2, a 4, and a 7. I just take all the stuff from each of those and combine it into one set. And that's it. The unions are the really easy ones. Just take everything and list it in there. Okay. When we look at the this upside down looking U, that's the intersection of the two sets. That's just the stuff that they have in common. So when I look at B and C, they have a couple things in common. The things that they have in common, they each have a 2, they each have a 4, and they each have a 6. So I just list all the things that they have in common, and that's it. I'm done. All right. The next one, it's the union again. So I just list all of the stuff. So I need B and C. When I list all of their stuff, it's 2, 4, 6, and 8. Okay, so I just list everything. The intersection of A and B, what do they have in common? So when I look at A and I look at B, they've got a -3 in common. A and B, I looked at A and D for a second, sorry about that. A and B, let's see, A and B, they have a 4 in common. And it looks like that's it. I don't see anything else that they have in common, just the 4. So that's the only thing in the set. The next one, when I look at A and D, this time I'm looking at A and D, it looks like they have a -3 in common, and that's it. I don't see anything else that they have in common, so that's the only thing I list. C and A, when I do the union of C and A, I just list all of their stuff. So -3, 2, 4, 6, and 7. I just list everything that I see in those two sets. Okay? D and B, again, the union, I'm just going to list everything that I see there. So D and B, they have a -5, a -4, a -3, a -2, a 2, a 4, a 6, and an 8. I just list all of that stuff, and that's my union. I take everything, and I just combine it into one set. All right? And then the intersection between D and C. When you look at D and you look at C, what do they have in common? And the answer is they don't have anything in common, which means this is going to be the empty set or null set. Okay? And if you just put an empty set of braces, or you just put the null set symbol, I'll accept that as well. Okay? For these last two, just drawing a Venn diagram for this. So again, this one, we're surveying students in terms of pens and pencils. So I'm going to call the pencils over here and the pens over here. And so for this one, it says that 350 students, we're surveying them. 295 use a pencil, which means this circle over here is going to have 295 values in it. That doesn't mean we're going to put 295 out in this section. It doesn't mean we're going to have 295 in this section. It means the total between those two sections is going to be 295. Okay? So we don't quite have enough information to write anything down yet. We've got to keep reading. But then it says that 152 use both. Well, that we can put down. That's the 152. That's the intersection. That's what they have in common. And so now here's the thing. If we know that the pencil circle is supposed to have 295 values in it, it's already got 152 values in it. We need another 143 values in order to get up to that 295 that it's supposed to be. All right. And now when we look at this a little bit closer, if there's 350 students here, well, right now I only see 295 listed. That means there must be another 5 that are over here in the pen only section. Okay? And so to answer the two questions, it says how many students only carry a pencil and how many students only carry a pen. And so that's the 143 and the 5. That's what those outer sections represent. They're the students who only have a pencil or only have a pen. Okay? This one, 200 children are surveyed by the Parks Department, and they want to know if they should build a new swing set and or a new slide. And so here's how the surveyed children broke down. Let's see, we've got the swing and the slide. And so when we look at the information that was given, it says that there were 12 children that said they only want a new swing. So only a new swing would be this section over here, so 12 students go in that section. And then it said that 180 children said that they want both, so that's the 187 goes in here. And we want to know how many children want a new slide. And so when we look at this, if there's 200 children total, well, right now I only have 199 listed, which means there's one child who said they only want a slide and no swing set. But now, the question doesn't ask, do they only want a slide? It says, how many children want a slide? So when I look at the slide circle, there are 188 children represented in that circle. Yeah, 187 of them said both, but still 188 total said they wanted a new slide. Okay? I hope this was helpful, and good luck on your test.